Hello, everyone. Mr. C here. Lesson number 9, the segment addition postulate. I want to just go over this brief example here. It says, make a sketch that matches the description. S is between T and V. You might start off by making a drawing. Just try to make sense of that. If you have T and V, they're on a line or line segment here. S is between them. We don't know where. You could put it in the very middle, and that would be fine. You could put it off to one side. It doesn't really say. It just says between, meaning on the same line segment. Then it goes on to say R is between S and T. Okay, so I find S and T, and I put R between those. Again, I don't know if it's in the middle or not. I put R there. Now, when we go in to read more, we might find that our drawing needs updated. In this case, it does need updated. Notice that it says TR, or segment TR, is equivalent to 6. So the distance from T to R here is 6. And RV equals 23. Okay, from R to V, that distance is 23. And lastly, TR equals SV. Now you can notice in my drawing, the segment TR and the segment SV do not look at all to be the same length. So you can do one of two things. One, you can just be okay with it and say, okay, my drawing is not to scale, and I'm okay with that. If you find it troubling, you might say, well, maybe I need to restart and make this drawing so that TR and SV actually look the same. So you do what you think works best for you. I'm going to go ahead and redraw it here from sort of the beginning. Okay, starting off again with R is between S and T. I'm sorry, let me go back one. S is between T and V. All right, we have T and V here, but I know S is between them. But now that I know that TR and SV are equivalent in size, I might measure off some length over here, and I might call that R, and I try to make about the same distance from V over here, and I call that S. That way, again, S is between T and V, and R is between S and T, and they look to be the same length of 6. So now when I go back and relabel it and say, okay, this was 6, it does look more visually like this also would be 6. And then we can reckon that RV would be, in fact, 23. Now, the question says, find SV, TS, RS, and TV, the other lengths that you could possibly find in this particular picture. So what you're going to do is use the idea of addition. If RV is equal to 23, we can also see that RV is made up of the segment RS. That's the first piece of the puzzle here. It's RS plus from S to V. All right. And if we know that RV is equivalent to 23, and we know that SV is equivalent to 6, we have a basic algebraic notation that we can write here. We can see, okay, something plus 6 is 23, and we can realize that RS is equivalent to 17. So using similar logic, you could solve, and that, by the way, was the solution to RS. You could solve for the other missing values as well. What is SV? We already had found that to be 6 from the statement above. What is the distance TS? That would be found by also realizing it's 23. RS is 17. And TV, the entire distance end to end, would be 6 plus 23, or 29. Let me briefly go over to GeoGebra to show you how you could work on this there as well. All right, so in GeoGebra, if you were to build a line segment, the issue would be that you don't necessarily have distances. Now, these labels are not going to be, T and V and S unless you change them. So I drew a line there. The problem is none of the distances are clear here. If you want distances, one option, let me click more, is to go, I think I have to click even more once again. So click more once again. If you go down to something called circle, center, and radius, again, circle, center, and radius, choose that. We've done this before. If you click one of these endpoints as the center, it will ask you, what do you want the radius to be? So for example, you could put 6. Notice that it needs to be zoomed out, and you can start building those distances by using the intersection feature that we talked about before. Now, in this picture, the distance from A to C is 6. You can build the other distances like the problem showed. So play around with that and have some fun.